This lesson on gas behavior. All gases will exert pressure. Pressure is due to the force of collisions of the gas particles against the sides of the container. So there are two different types of pressure. There's internal pressure. The internal pressure, that is due to the particles inside the container hitting against the sides. So as it moves around, the particles are running around, they're on the gas particle, running around, so it keeps on hitting the sides. That force hitting to the outside causes an internal pressure. Different from that is atmospheric pressure. Atmospheric pressure is different in that it is due to the weight of the air above it. So that if you have more air above you, you have more air pressure, or atmospheric pressure. So if you are, here's the Earth, and we do this at sea level. So if you're at sea level, you have all this pressure above you. If you're on top of a mountain, you have much less air above you. Storms cause ripples in the atmosphere. Sometimes there's high pressure or fair weather. Sometimes there's low pressure or stormy weather. So, due to the fact of the air pressing against you, would cause you to have atmospheric pressure. If you are in equilibrium, or if you're not increasing or decreasing or anything, the internal pressure and the atmospheric pressure are equal. So what can you do to affect pressure? What are factors that affect pressure? Affect pressure. Well, one of them is the number of particles in a container. If there are more particles, the more collisions with the side. More collisions. Therefore, the pressure goes up. If there's fewer particles, if your tank springs a leak, or if you're using air and helium to fill up balloons, you're removing some of the gas particles, then the pressure goes down. Why does the pressure go down? Because there are fewer collisions with the side of the container. Temperature or heat is kinetic energy. The higher the temperature, the faster the particles move. So if you have a higher temperature, the particles move faster. And therefore, there's on two factors. There's more collisions because they're moving faster, and each collision that they do have is more powerful. And the last one is the size of the container. If you decrease the size of the pressure, if you decrease the size of the container, there's less surface area for the same number of collisions, less surface, we'll continue on down here, for the same number of collisions, so more force per area. These and other things can be explained by the kinetic molecular theory. KMT's abbreviation, kinetic molecular theory. Different textbooks have different. This one has 6 postulates, or basic assumptions is what they are. Matter is made of very small particles which have mass. That have mass. Even though they're small, they do have some bump to them, like wind blowing against your body. The distances between the particles is huge. Is huge compared to the size of the particles themselves. These particles are moving constantly, rapidly, and randomly. The collisions with the container or any collision is perfectly elastic. In other words, they don't lose any energy. They just keep on going on forever and ever. So the collisions are elastic. They would bounce forever in between each other. No energy is lost. The temperature of the particles, the temperature is directly related to the kinetic energy. The higher the temperature, the higher kinetic energy, the lower the kinetic energy, the lower the temperature. In the gas particles, particles have no attraction repulsion between each other. Between them. It's like they are off in the world by themselves. They only know that the other gas particles are around. Okay, these I explain in ideal gas. An ideal gas is any gas that follows all these postulates. Again, the postulates are just basic assumptions, simplifications of how complex Mother Nature is. True gases postulates. True gases, or real gases, do not. And there is no ideal gas. Helium is the best one that we have. It follows the postulates for the longest amount of time. Real gases, or that means all gases, do not. But it's okay for most conditions. If it's around the temperatures that we can survive and exist, like Antarctic to hot gases someplace, we are good. If it's talking about atmospheric pressure, 2 or 3 atmospheres of pressure forcing against us a little bit stuffy, but still there, or rare mountain air up in the mountains. These all follow out. The real gases and the ideal gases, the real gases fail at very cold temperatures. We're talking about a couple of hundred degrees Kelvin above absolute zero, and or very high pressure. What this does is it forces the particles to move closer together, or they're moving very slowly. If they're moving very slowly, they have a chance of attraction between them, which there is a very small amount of attraction, and that's one of the postulates that fails. The failing postulates is attraction force. There is an attractive force between the particles, however very small. But if it's moving very quick, or if they're very far apart, there's no chance for that attraction to take hold, clump them together, and make a liquid. When we talk about the postulates failing, that means we're talking about turning from a gas to a liquid. So attractive force is the main one that fails. If you're moving very slowly, they can have a chance to come in contact and the attraction overcomes the bounce. And or the high pressure, if they are really smushed close together, then they have a chance for attraction to be taking effect. And then the last stuff is diffusion and effusion. Diffusion is when a gas passes through another gas. Example here would be a perfume or something. You squirt perfume or room freshener at one end of the room, and eventually you'll smell it at the other end. And the last thing is effusion. It's where gases pass through a pinhole or a small hole. This is like helium balloons in a latex balloon, helium gas in a latex balloon. You have helium gas in a latex balloon. When it inflates, it creates little tiny holes, and because helium is so small, it can easily pass through these holes. If you blow up a balloon, it'll stay full longer because air particles, carbon dioxide, oxygen, nitrogen, are much bigger than nitrogen, and it takes longer for them to pass through the holes. That ends this lesson on gas behavior.